well. So just by way of introduction, this is me. My name's Connor McDonald. You can get in touch with me in all sorts of ways because I do like talking technology when my throat's not this bad. Easiest way for casual conversation, please follow me on Twitter and we can always talk tech nice and easily there. If you prefer longer form stuff, you can get my blog, connormcdonald.com. Or if you prefer video, I've started doing tech videos. I've got a few hundred up there now at YouTube, Connor McDonald Oracle. So all sorts of options there. I also have a podcast. This is what I do most of the day. You may have heard of the asktom.oracle.com website. It's been going for about 21 years now. Myself and Chris Saxon, we look after the Q&A there and another avenue for you to ask questions of us. It used to be obviously Ask Tom for Tom Kite. We now renamed it to Ask the Oracle Mentors. If you've got database questions, we would love to try and help you. Our objective is to make you more successful with the Oracle database. Now, before we begin, as I say, whenever I've been doing a talk for the last 18 months, it's great through virtual connections because we can reach people we've never met before. But the reality is it would obviously be better if we could meet face-to-face, where we can actually really talk in a more friendly and open manner and while still improving our tech knowledge. So please follow your local guidelines, follow your local laws, etc. Let's get ourselves vaccinated so we can get our communities back together. The fact that we've managed to get this tour running virtually is a great credit to the organisers, the OGP EMEA team, but I think all of us would like to be back in person as well. So a few ground rules for this talk, because I'm talking about PLSQL. This is not some sort of religious debate. And this is one of the probably the things that holds PLSQL back, is there are a lot of people out there that say you must use PLSQL absolutely everywhere or you're failed in some way. There's been a lot of sort of a religious almost, passion about the PLSQL language. And as a result, when people say, well, I don't need it all the time, they get criticized or shouted down in public, which I think is a real shame. All I care about is you as Oracle customers having successful applications. If we can do that, that's really all that matters. I'm not biased toward PLSQL or any other language. I just want you to have the most success you can have with the Oracle database. Now, let me explain what my definition of success is. My definition is obviously an application needs to meet its business objectives. That's obviously every application needs to meet what the business demands of it. It needs to meet its performance objectives. It's no good if it can do the functions it needs to do, but it takes 10 hours to do them. That's really obviously a business objective as well. It needs to meet its development objectives. It doesn't matter if an application is fantastic if it takes 20 years to build one, or it's impossible to maintain, or very hard to test. It's got to make its security objectives, and that becomes more and more important every single day. The days of uptime being the most important thing for applications has pretty much disappeared nowadays. Nowadays, it's all about security, because if your application goes down, people generally will forgive you. If your application gets hacked, then you're generally going to be out of business. Now, let's be real. All of these things are really about money. Your business exists and builds tech applications typically to achieve some sort of commercial gain. So hopefully, if we can meet all those objectives, our businesses are going to be more successful. Ultimately, can PLSQL help you make more applications and spend less money? So the question that comes to me is, how can something as simple as PLSQL, just a language choice, be that pivotal in the way our applications may or may not be successful? So let's walk back to the origins of PLSQL. When did it really start to become popular? It's back in these days. If you're a dinosaur like myself, you remember we used to build applications in forms, and this was the client-server revolution. I remember in the mid to late 90s, everyone was saying that client-server was going to be the future of computing, and we all saw how that went out. If we look at the problems with client-server, I think the best way of explaining why client-server really struggled in terms of building applications that were successful is if we look at client-server in real life. Let me do a little new share for you. Okay, hopefully you can see that video. So this is me mimicking a client-server application. We get out of bed, grab some cereal, dash of milk, put it away, get it out, grab some cereal, dash of milk, eat the cereal, put it away, grab some more cereal. That looks like a data corruption, etc., 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 etc. That's how we built applications back in those days. The problem with the client application and a server that was remote was the chattiness and the latency between them. That's what killed our applications. And of course, people would say, we would never do that in real life. I mean, who eats their breakfast cereal one piece at a time? That's stupid. But funny enough, that's exactly how people built their applications and then got upset about the fact that they didn't run particularly well. This is where PLSQL really came into its first head, because it was the ability to do less work on the client and more work on the database. But everyone did this, as we said. Everyone built applications that were slow and used PLSQL as a way of solving that problem. And then what happens, of course, is when app servers came along, when the internet came along, and all of a sudden we weren't running applications on the client, we were running them in the application server layer. People thought, fantastic, now that the app server is right next to the database, I don't need PLSQL anymore. And that's pretty much the mentality that's come along ever since then. Even though we're now running more client-rich applications with JavaScript in the browser, people still believe that because the application logic or programs run on the app servers, we don't need to have PLSQL anywhere in our stack. So as we say, is PLSQL still relevant nowadays? So let's remember that definition of success: performance, maintenance, security. Now, a little small digression here. You hear this thing called utopia, and utopia is basically the perfect application. And if you search on the Oracle websites, you'll see numerous references to a thing called SmartDB. It looks like this. This is, in theory, and I stress in theory, the perfect application from a database perspective. So we have the data in here, then we have a code layer on top of that, then we have an API layer on top of that, then we have a JSON layer on top of that, and it all hooks through ORDs and it all hooks through firewalls, etc., etc., etc. If you search for SmartDB, you'll see these templates. And SmartDB, don't get me wrong, if you go down that route, will almost guarantee you to give you incredibly successful applications. And here's a link if you ever want to pursue that route. But here's the thing. When we talk about utopia as being the perfect solution, a place where state is everything is perfect, that definition is not actually correct. If you look in the dictionary, the definition of utopia is actually an imagined place. So while SmartDB is fantastic from a theoretical perspective, I think the reality of implementing it in the real world, in real commercial applications, is probably not realistic. And in fact, if we ask the amount of people using the SmartDB in its full description, it's very, very low out there in the workplace. I've certainly only seen a couple of customers ever really go that entire solution. And here's what I hate. When I remember I said this wasn't about a religious argument. Just because people aren't using SmartDB, I've seen people who are very biased toward Oracle say, well, that means you're failing. If you're not using SmartDB, you're failing to write good applications. And of course, that's nonsense. There's plenty of successful applications that don't need SmartDB. Similarly, other people have gone down the SmartDB route and said, okay, I've implemented most of the principles of SmartDB, but I haven't done all of them. And same thing, there have been people in the past that say, oh, in that case, then you've failed. That's fail, because they're falling back to a philosophical argument. The theory is, if you're not achieving this perfection, then somehow you've failed as an application developer. I want to get rid of that whole premise. I want to forget about philosophy, and let's just focus on the things that really matter as application developers. That is, do we make successful applications? And can even just a little bit of PLSQL help us achieve those successes? So for the rest of this talk, let's forget about SmartDB. Don't get me wrong, it's a great solution, but it's an enormous undertaking. It's a big, complicated undertaking. If you can do it, great. But just because you're not doing it don't think, oh, I shouldn't even bother with PLSQL. That's a bad option. So let's look at our, excuse me for a sec. Let's now look at our definitions of success. So let's start with performance. Remember I said it's okay now that we have app servers. The app servers are very close to the database, therefore we don't have to worry about those client-server latencies, therefore PLSQL might not be required. But the reality is, no matter what platform you're using, whether it's Python, whether it's Java, whether it's Node, whatever language on an app server you're using, you're getting data from the database. And in fact, it doesn't really matter what direction, you're pushing data back into the database as well. Every application platform does what you see on the screen there. It talks to the database to send information to it and gets data from it. The problem is people rarely do what you can see on the screen there. More realistically is they do things like this. In the application world, especially once we start abstracting the database away, we have a lot of information and a lot of calls going back and forth between the application server and the database. Yes, they're generally co-located. Yes, they're connected by very fast networks. But the reality is the laws of physics and the speed of light intervene. That many calls is going to cost you. And that leads to this classic thing where people go, oh, the database must be the problem. I've got this application, it's doing billions of database calls. I can't get the work done, so the database must be slow. Yes, we should all go use MongoDB. Let me prove the fallacy of that argument. We're going to evolve to PLSQL, a solution to try solve that issue in little tiny steps. And the first thing is getting past that first fear that a lot of application developers have when they get told, maybe try PLSQL, is that it's another layer of code. People think, well, if I'm doing a simple query from Java to the database, and now you're asking me to go from Java to PLSQL to the database, then by definition, I'm doing at least my query plus more work. It's going to burn more database CPU, and therefore it's going to cost me more in terms of performance and obviously money as well. So let's explore that. Let's start with the simplest possible app we can think of. It just does primary key lookups. So here's the Java version. And we can see we don't have to go too much into depth here. It's simply doing select a column from a table where a primary key equals a value, and I'm going to loop around 20,000 times doing 20,000 primary key lookups. If I'm going to migrate that to a PLSQL solution, first I create a little PLSQL function which does that SQL statement for me. And then my Java program, same thing, 20,000 loops, simply calls that PLSQL. I've done no refactoring here. It's not like I move those 20,000 calls into the database. I'm still doing 20,000 calls from the Java program to the database, one being a direct SQL statement, one being a PLSQL call. Let's give that a roll and see how it runs. So this is our Java program that's just doing the SQL calls straight from the Java program. You can see it did 20,000 SQL calls in about 2.6 seconds, and it used 46 centiseconds of database CPU. Let's now compare it to the PLSQL version, because I wanted to be very upfront here to show you what happens. Now, the PLSQL version, this is how people think. They think, well, Java calling PLSQL, that's another layer. Then that talks to the database. You can see it actually took a little bit longer and used more database SQL, CPU. Back to our slides. And so people go, they absolutely freak out. They go, I knew it. PLSQL must have been more expensive because it's just more layers in the stack. And it's true. If your application does only primary key lookups and nothing else, PLSQL really doesn't have a lot of benefit for you. But then again, neither does a relational database. If you're just doing primary key lookups, I would simply use our autonomous JSON service and the job is done. Why would you bother with a relational database if all you're doing is primary key lookups? The sad thing is, sometimes we want the power of a relational database, but our application just does primary key lookups because we're using an ORM. There's sort of an interesting irony here, though, because people say, well, you know, if you have more layers by introducing PLSQL, then by definition it's more expensive. But it's funny how we used to write applications like this. Java talks to the database. And nowadays we have applications that have 1 million layers around the database. And we easily justify them. But the moment someone says, oh, we should use PLSQL, they go, oh, no, we can't have too many layers. It's a bit of a hypocrisy, I think. But let's now make it a little bit more real. Rather than an application just being a primary key lookup, let's do a slightly more realistic application. This one does some API calls. So this one is, rather than just doing a simple call, I'm getting some customer details, their region, I'm getting their orders and looping through them, and I'm getting a count of the number of items for a particular order. This is the kind of thing applications do. They actually run multiple queries to satisfy a business function. I can take that and also move it into a PLSQL call. I'm getting that same region, looping through the customer orders, and then getting the total number of orders, items for a particular order, and I'll call that inside my Java program. So now we're adding a bit more realism to our application. Let's try that demo. If I can spell. So our simple API, now we're doing 3 times the number of SQL calls across the network from our Java program. 20,000 iterations, it took 7.7 milliseconds and used 123 centiseconds of database CPU. Let's now try the PLSQL version. I think this is a much more realistic representation of why PLSQL has a place in your enterprise. Once we start getting into more realism, i.e. talking about APIs to the database to do business functions, you can see now this is twice as fast. And even though we're running the exact same SQLs and calling a PLSQL program on top of that, we actually used dramatically less database CPU. We'll come back to that. So a couple of key points there. Number one is, this is not a network latency issue. I'm running all these demos on the same machine here. It's Java talking to my local database running locally. So it's not a network latency issue that made the application run twice as slow. And the interesting thing here is, notice we used less database CPU. We did the exact same amount of SQL work and we ran PLSQL programs on the database. And yet the net result was far less database CPU. We will return to that shortly as to why we use less, but keep in mind that whenever you use less database CPU, do you know what that is? That's money, because you pay your database licenses based on CPU count. So anything that uses less database CPU will actually save you money. The counterintuitive thing here is that moving your code into PLSQL and running it on the database server used less CPU. Now let's make it really real. These are very small little 3-query applications. I'm going to use a thing called SwingBench. SwingBench is a genuine Oracle benchmark tool written by a guy named Dom Giles, who's back at Oracle now. It is a order entry benchmark. You can build your own benchmarks as well, but in reality, you can actually run fully fledged applications, and they're Java applications. One of the cool things that SwingBench gives us is it gives us the identical application in the same way we just saw there. All the SQLs are running out of the Java layer, or all the SQLs are running from PLSQL calls. Exact same amount of work, just where the code is being stored is different. So we can actually test that as well. This is now a real life application. It does queries, lookups, inserts. It's basically an order entry benchmark. Let's go back to our command window. So SB client is running SwingBench client, where all the queries are stored in the Java layer, and they're just being sent across to the database. Well, that looks very, very slow. That doesn't look right at all. Oh, maybe because we're running Zoom. Let's get that a little bit of time to ramp up. I think that's even very slow for a client-based version. So this is where the TPS there is transactions per second. That seems a bit slow, but let's compare it to the server one. I think the server one's going to be dramatically faster, which suggests I don't think my client one's configured correctly. Or maybe because we're running Zoom. Seems a bit slow. Okay, I'm going to run them once more again, and we'll see if we get some better numbers. Maybe not. Maybe Zoom's choosing up all my resources here. We should normally get a fairly consistent result. This looks a bit better. So SB client is all the SQLs being run straight out of the Java layer, and I've let that run for a little while now. And if I kill it off, I'll just hit enter. It'll give me an estimate of how many transactions per second I got. I got about 55 transactions per second. Let's run the SB server. Hopefully this won't make a liar of me. It starts to ramp up. Let that run for a little while. Whoosh. Obviously something has cleared the path. I'm guessing I may have... Well, okay, let's kill that off. I don't think it's a realistic thing to say we went from 55 transactions per second to 255. You'll probably just need to take my word for it. Where's my slideshow gone? It's probably the fact that I've got Zoom and the meeting recording and a lot of other things going on at the same time, and obviously it's trying to push data back and forth. In reality, we normally see around about a 20 to 25% performance boost by having the code in PLSQL for real-world applications like Swing Bench. So the key thing is that Dom Giles is a very smart guy. That Java program he's written, it says SQLs there, is the best that Java and any other program can do. There's nothing wrong. They're not architected badly. They're not written badly. They are simply paying the price of sending SQL statements across to the database server instead of PLSQL calls. So hopefully that proves to you that if you can move code into PLSQL, you get performance benefits. And let's now look at the second objective for success, which was development. For developers, there's two things that really matter: how easy it is to build applications and how easy it is to maintain them. And can PLSQL help in these two areas? Let's start with build. Benefit number one of building in PLSQL is this thing: crashing early. There's a great book called The Pragmatic Programmer, and it says a dead program does a lot less damage than a crippled one. If a program is not correct, you don't want it running, as opposed to running badly. One of the problems with almost any 3GL is generally we present SQL in the form of strings. So I've got for example here, it says, select any old piece of crap from Joule. That's obviously an invalid SQL. But because it's just a string, when we compile it, you'll get no errors. It's only at runtime do you discover that that SQL statement was wrong. Compare that to PLSQL. Literally, it's at compile time that you get told that SQL is obviously invalid. That's a productivity boon for developers, because now rather than having to compile and run unit tests, you literally get told straight away that as you're almost entering this stuff, yes, that SQL statement is invalid. If you're using some of our Oracle IDE tools, literally as you're typing that SQL statement, it's going to underline it and show that the things are not correct, things like SQL Developer. The second benefit for developers is PLSQL. When you code SQL statements in PLSQL, the lazy way to do it is the best way to do it. Now, lazy sounds insulting. Let's call it the efficient way. What do I mean by that? This is the easiest way to code a SQL statement in Java. Simply do execute query, pass in your statement. That's the simple and easiest way to do it. You're meant to do it with a prepared statement. The reason it's important to do a prepared statement is because if you don't, and because that's longer, that's like, about four or five longer lines of code, people don't bother because developers are often a little bit slack when we come to writing code. But if you do it the lazy way, simply building up SQL by concatenation, you get hacked. Because if you're expecting someone to type in an employment number, for here's my SQL statement up here, and you're expecting someone to type in 6443, well, I'm just going to type in this, 6543 and 1 equals 0, which removes that query. And then I go looking in your all tables catalog for the tables that have the name security. If I find one, then I'll pass in this as my employee number. Once you allow user inputs to simply go into SQL statements, you're asking for all sorts of security problems. And as we saw before, security will kill you nowadays. Whereas in PLSQL, the easy way, just query like that, right? It's hard to write dynamic SQL. The easiest way to write SQL in PLSQL programs is what we call static SQL. It's compiled and cannot be hacked. It can't be SQL injected. To actually build a SQL statement from scratch using strings in PLSQL is long and cumbersome and time consuming, which means people don't do it. Sadly, we introduced this thing called execute immediate back in Oracle 9, which actually does make it easier to run dynamic SQL. I wish we hadn't. I wish we left it as this one down the bottom here, because ultimately we always want to be encouraging people never to build up SQL statements using strings because the risks are very, very high. People say, it's okay. We don't build up our SQL strings by ourselves. We use ORMs to do that, therefore we're going to be safe. But don't forget, ORMs are just applications written by other developers. So even ORMs can be found to have security holes. This was a famous one that basically found that this ORM itself would actually open you up to SQL injection. An ORM carries just the same risks as you writing your own code. It's not just an issue of static versus dynamic SQL as well. Remember I said I'd come back to why the performance was better using PLSQL-based code. Here's my query, select ename from the employee table where job equals sales. If I run that from SQL Plus or any tool, Java, etc., I just need to parse it, execute it, and run it. If I put it in PLSQL, let's look at what happens when I put a trace on it. I parse it once, even though I executed it many, many, many times, and even though I fetched from it many times, I can see I get these things called bulk fetching. I did 10,000 fetch calls, but I actually did 40,000 rows. So I got benefits of parsing, and when I did fetching, I actually managed to fetch them in batches of rows. These are optimizations that most of us already know about, but PLSQL does them for you automatically. Minimal parsing, array fetching. And therefore the result is 0.25 seconds of CPU. The exact same SQL statement thrown to the database, written correctly. This isn't just basically SQL concatenation. This is a bound statement. Gives me this by default, 10,000 parses. And I had to do 40,000 fetches to get 40,000 rows. Out of the box, the simplest Java programs don't have those efficiency gains that PLSQL has, and that's why your CPU consumption goes up. More database CPU means more money you spend. Now, don't get me wrong, you can get around this by adding more code to your Java programs. You need to set some statement level caching and set array fetching, etc. But once again, it's more code that needs to be checked, more code that needs to be written, and more code that needs to be tested, etc. Often people don't do it, and with PLSQL, it's done for you. People often say, well, 20% benefit in performance, I don't really care about that. That's good enough for me just writing my stuff in Java. I would accuse people who say that as being a little bit of a hypocrite, because the same people that say, oh, I don't need 20% more performance are the same people that say, oh, we have to head down the route of microservices on 1,000 node clusters, etc., because databases don't scale. Well, the reason databases don't scale is because you're not using PLSQL. A third benefit for development is that no application is 100% complete. What do I mean by that? Once your application is built, it's normally built for the standard day-to-day usage. Often when an application has to be first deployed, we might need to do some data loading, or once an application is running, sometimes we need to do some data patching and there isn't an application API to do it. Having code in PLSQL means those functions in PLSQL can be reused in things like data loading and data patching facilities. You don't have to write a brand new application to actually do these ad hoc requirements. A common build criticism, a common reason that people don't like using PLSQL for development is they say, well, there's no private sandbox. Normally when developers build their applications, they do it all on their own machine, on their own private copy of the application, whereas PLSQL by design is normally a shared facility inside a shared database. That's true in the past. However, nowadays with things like free cloud tenancies, where you can literally fire up databases for free, you can also have multiple pluggable databases now, and as long as you're on 19C or above, it costs you nothing. You actually have up to 3 pluggables in 19C, and all editions costs you nothing. Similarly, if you're using Express Edition, From 21C Expression Edition onwards, you can have unlimited number of pluggables, and it's free. 21C Expression Edition is 100% free. So the argument now of, oh, I can't have my own pluggable database and my own private sandbox, we've got rid of that now with our free offerings. You can do it free on the cloud, or you can do it free on your own machine with Express Edition. There's nothing to stop you from cloning pluggable databases from a central server onto your own laptop, having your own private copy of a database to do whatever private sandbox testing you'd like to do. Let's now talk about the second part of development, which is maintenance. One of the benefits of PL/SQL in terms of maintenance is you get free dependency analysis. For example, we have this view called DBA dependencies. There's also user dependencies and all dependencies. If I wrote a procedure called, for example, my procedure, it references the Scott employee table. Well, when I come to add columns to the Scott table, how do I know? How do I know what things are going to be impacted? In my Java tier, I simply have to start, scanning for the reference to the word emp and try work it out from that. In PL/SQL, it's all tracked for you. In DBA dependencies, it says this procedure called my procedure. It depends on the table called emp. It also depends on a package called standard, which is the standard. Oh, recording has stopped. One second. A common maintenance criticism of PL/SQL is that deployment means downtime. We've all had that issue of we want to make changes to a database and you're changing code in the database, for example, a trigger or PL/SQL, and that code is in active use. And sometimes we get stuck on a library cache pin. Therefore, the only way of getting that is to shut your application down, deploy the new code, and start it up again. There are plenty of facilities in PL/SQL to avoid that issue. Number one is packages which break the invalidation chain. If you just write procedures in PL/SQL, procedure A equals B, B equals C, C equals D, and you change D, C, B, and A all get marked as invalid and need recompilation. That's a resource cost and can create some contention issues in your database. However, if you use packages for everything, package A has a spec and a body, B has a spec and a body, what happens now is if you change the package body for D, everything else stays valid. That lets you now deploy changes to package code without having any invalidation. It solves that contention issue. From 11G and beyond, which hopefully all of us are now on, you can even add things to the package spec. As long as they're added at the bottom, you get no breakages in invalidation. Once again, there's no issue deploying those code changes in real time. And in 12C and beyond, we have addition-based redefinition, which means I can have version 1 of my code in active use on a database, and I can roll out version 2 of the same procedure in advance before people even get to use it, and I can slowly flip people over to using the new version. I can have multiple versions of the same piece of code running at the same time on my database. Just returning briefly to Utopia on this edition-based redefinition, a lot of the white papers on EBR talk about going similar to SmartDB, going an entirely complete EBR solution, i.e. you have to rename every single table as a view. You have to create these things called cross-edition triggers. You have a lot of complexity. You don't have to do that, even though a lot of people say you should. The easiest way of using EBR is simply saying, whenever I just need to change PL/SQL code, I'll use EBR for that. If I'm doing some wholesale changes to my application schema, tables, etc., then I'll do what I normally do. I'll take some downtime and do it. But the reality is those kind of changes are much less frequent than just code fixes. Code fixes, you can use EBR for PL/SQL and roll out changes in real time and slowly move people over. It reduces your risk and it keeps you up as well. You don't have to worry about going 100% EBR in the same way you don't have to worry about going 100% SmartDB. So hopefully I've covered performance and I've covered security. Let's now cover, I've covered performance, I've covered development. Let's now cover security. Benefit number one is PL/SQL doesn't necessarily inherently give you better security. It gives you an opportunity for better security. This is one of the sad things I often see when I visit customers is you look at VDOLA session and they've got a connection pool. It's all coming from Java and it's all logged on as the schema that actually owns the application. Excuse me. or hopefully we'll get through. That is an enormous security risk because any code now is running as the schema that actually owns the tables and objects. So any piece of strings inside your Java program, like drop table, truncate table, etc., will run quite happily because it's logged on as the schema owning. This is probably the worst security setup you can ever have with an application, all the connections coming in as the schema that owns the table. Hopefully no one ever does this. Now, there isn't a limit on schemas in the Oracle database. You can literally have hundreds of thousands of schemas, just a matter of space. And the best thing to have is what we call least privilege. So the more you can lock down privileges without going too complicated is generally going to be the best security mechanism you can have. So the easy way is nothing should ever connect to the owner of tables, ever. This means you have something that looks like this. You have an application schema that connects to the database. It might be a connection pool, etc. And it has insert, update, delete, and select privileges on all your tables. That might seem the same as what we just had. I mean, I've just removed the schema one layer. I can still delete all the data from a table, etc. This is even still a better level of security because now you've taken away drop, you've taken away alter, you've taken away truncate, you've taken away those various facilities that are so damaging to tables if they get in the wrong hands. Yes, delete is still an issue, obviously, and so is update, but at least you've improved your security layer at least by one. But once you have a separation of who you connect as and who owns the objects, now you can move to a PLSQL-based model, which is far more secure because now the PLSQL sits in my schema, and the only thing the connecting application can do is execute PLSQL programs. So the only way it can talk to the database is via PLSQL. It can't do erroneous deletes. It can't do erroneous updates. It can't do anything malicious. The only way you get problems with your data is if you have bugs in your code, and there's nothing we can do about that. Now, that in itself is perhaps a complicated undertaking because let's face it, a lot of our applications like querying the database. And so even doing something like this, I believe, is a happy solution and just as good. That is, if I'm doing insert, update, or delete, PLSQL takes care of that for me in nice APIs to do the business functions. Queries, I'll let the application query the schema itself directly. This is pretty much how Application Express works in most common implementations. There's minimal risk, hopefully, of letting people select. Obviously, if you have sensitive information, you need to control that. But in a general situation where people are allowed to query the data, having select privs out here and execute privs on PLSQL programs that do all the changes to data is a great, happy compromise of getting security and minimal risk of data damage. The second benefit in terms of security is once you have PLSQL recorded like this, you don't need triggers anymore because, oh dear, that's no good. I just pressed home key. Oh dear. Where was I up to? I reckon about 140. Oh, that was close. Once you have code that looks like this, where the only thing that an application that wants to change data can do is call PLSQL programs, you don't need triggers anymore because triggers are normally the kind of code we put on a table because we don't know where the DML is coming from. We have 10 programs that might be issuing DML directly. We want to make sure that we catch something that happens no matter where the DML came from, the insert, update, or delete, and so we put a trigger on. If it's all coming only through PLSQL, you can put the trigger code in there and not have triggers at all. And the reason that's a good thing is because triggers are harder than you think. One of the most common issues I have with data corruption with customers is when they think triggers are doing things or firing at the times when they actually aren't. For example, changing a single row in a database might fire a trigger more than once. So let's put all that theory now into practice. This is a real customer example, and hopefully this demonstrates why just a little bit of PLSQL is all it needs. Before I joined Oracle, I worked for a very large gambling organization here in Australia. And to give you an idea of how much Australians gamble, on a particular day of the year, this application was doing $10 million worth of people's gambling money every single minute. We have a big race coming up in the start of November. It's called the Melbourne Cup. It's such a big horse race that some parts of Australia have a holiday in order to watch this horse race. That's how obsessed Australians are with gambling, which sadly is the case. So this application was taking in $10 million per minute over thousands of complex transactions per second. Now, the development team for this application, when I joined them, were generally C++, C# developers. They didn't have any Oracle experience. And when I was working, I realized they had no database experience at all. They'd all been written in process level control applications where you threw away the data. They didn't actually have anything where they did in terms of persistence. So the application looked something like this. It was C#, C++, a service bus coming through Oracle Tuxedo, all routed through WebLogic, going to the access the database. Now, those arrows aren't a true picture of what was actually going on. This is perhaps a better picture. Because they were obviously C# and C++ developers with very little database experience, they were doing all their SQL, all their business logic right up in the C++ tier, lots and lots and lots of trips to the database, and therefore they were having problems. They simply couldn't get the thousands of transactions per second that they needed for these big days of the year where people were gambling so much. Systems would time out, they would start crashing, and therefore they said, we need some help. This is when I got involved with them. And when I looked, they had literally all these APIs written in C and C# and C++, which represent all the things that people do in a betting environment. A race will start, a race will finish, a new customer will come along. People want to deposit money into their account, or horse gets removed from a race, it's called scratched, etc. They literally had hundreds of little APIs describing all the business functions of gambling. And don't get me wrong, I'm not trying to be critical of our development team. These guys had written beautifully well-structured code. It was just all up in C++ and C#. All we did across all those hundreds of APIs was move 2 of them to the database. And those 2 were literally about 90% of the application volume. And you can see that was what they were. The first one is a customer places a bet. They're the transactions that come in thousands of times per second. And when a horse race finishes, the next thing they do is they want to see if their bet was a winner. So the 2 most popular routines in the application were a customer places a bet, we move that to PLSQL, and pay if it's a winner. When the customer comes back and says, did my ticket win any money? Just those 2 C functions got moved into the database in PLSQL, and that was it. They were happy, right? That got them now achieving thousands of transactions per second, because the other 10% of the application didn't have enough volume for us to bother about moving it into PLSQL. But the reality is the benefits can be addictive. As I just described, when we started off, we moved a tiny bit of PLSQL and we had the vast majority of the application still in C#. But over time, these C# developers and C++ started saying, can we move this into PLSQL? Can we move that into PLSQL? And over time, more and more stuff ended up being PLSQL calls and less SQL logic being in the upper tiers. Another example is from a good friend of ours who lives in Israel, Oren, who actually said with one of his customers, they added a single procedure to solve one problem, then another PLSQL procedure solved another problem, and then very quickly they want PLSQL everywhere. Once you see the benefits of PLSQL, it becomes very, very addictive. Now, I just want to address some of the common criticisms of PLSQL before we wrap up. Most modern languages nowadays are object-oriented. We know that. Oh, my dog has come to visit the call. And people say, well, PLSQL's not. It's an old language. It's more procedural. But what are the principles of object-oriented? Those principles are, if you have attributes, then you protect them and you encapsulate them with methods. That's the basis around object orientation. You deal with the methods, you don't deal with the attributes directly. But what is PLSQL? PLSQL is a layer that exposes APIs to protect attributes, those attributes being data. So yes, it is a procedural-based language, but its principles are very much rooted in that of object orientation, i.e. you control access to the data via APIs. PLSQL is designed explicitly for that purpose. And people say, oh, we don't have any PLSQL skills though, because let's face it, most people coming out of college nowadays are going to be learning Java, JavaScript, etc. They're not going to be taught in PLSQL. But let's be realistic. It's a procedural language. So many of us probably got started with BASIC or Pascal or maybe even C. It has all the standard structures that every language has. If then else, loop, subroutines, parameters. The last thing I think anyone could ever accuse PL/SQL being is overly complicated. I would contend I could teach anyone to write PL/SQL programs faster than I could write in C++. And probably the final thing that people often come back with is they say, well, no matter how much you convince us that it's good to start moving logic into the database, well, the reality is we struggle with SQL, or we struggle to write good PL/SQL. It doesn't really matter. As I said, we're not after utopia here. Simply by having code, even if it's not great code, into the database gets you performance benefits, gets you resource consumption benefits on your database server, which, as I say again, is money, right? And you'll be amazed at the results. It's not about utopia, right? As I said, don't think that to move to PL/SQL means I need to move all of my application to PL/SQL. Just a little bit of PL/SQL can go a huge, huge way. I'm just going to wrap up now, so we'll have some time for Q&A if you need some. I keep stressing, it doesn't have to be a war, right? Please, if you're an Oracle person, as in like you use Oracle for a long time, please don't get in that habit of going and talking to your developers and saying, if you're not using PL/SQL for everything, you're a failure. Conversely, if you've never used PL/SQL before, don't feel frightened that if you need to use some, you need to write your whole application in PL/SQL. There's plenty of happy compromises in there as well. It never has to be utopia, right? Please forget about philosophical battles. Most of tech battles on the internet are philosophical ones. They're never actual genuine ones about customer success. If you can get performance, and if you can get development benefits, and if you can get secure applications, then that's all you need. PL/SQL is just going to be a stepping stone to help you get there. I honestly do believe that PL/SQL is easy to learn, easy to write. I had to pick up PL/SQL with no training. I literally, I think I did Pascal at university, and I realized that PL/SQL was very similar to that. It's obviously based on Ada originally. And people often think, well, I don't want to get involved in PL/SQL because it's been around for so long, then maybe it won't get any innovation. But innovation continues. If you go to the just released 21C new features manual, you'll see we've actually done a huge amount of changes in the way that we iterate through data and collections in PL/SQL. So there's an active team still building, still bug fixing, still doing a lot of work on PL/SQL. And as we saw, the best thing about PL/SQL is you can get some really big wins, especially in the performance area, for small amounts of effort. And I think it's important to recognize that small effort is just as important as big wins. No one wants to get big wins with a 12-month coding exercise. Much better to be able to do small things and get big wins for that effort. And the best thing is, as I mentioned to other customers, you'll be amazed at how often that if you just have a little bit of your application in PL/SQL, very soon you'll be interested in moving more and more to PL/SQL as your project continues, because you just keep seeing the immediate and long-term benefits. It just needs a few little baby steps, and I used this picture the other day. Here's my son. He's getting very involved in PL/SQL very, very early, and I cannot help but encourage you to do the same. That's it for me. My voice is just about toast. Let me just pop to the chat line now and see if there's any questions. The dog looks bored. The dog does look. I do feel very sorry for my dog. Let me stop my share. Yes, I must say I do feel very sorry for my dog. He gets to sit and listen to me do webinars probably 2 or 3 times a week, and he'd much rather be outside in the park. So thank you very much. He looks like the Kowalski penguin. Who's the Kowalski penguin? Can someone explain that to me? I'm not a...
There's even written a definition about what it's like: intelligent, calculating, and leading the way to wisdom.
Well, I'll take that as a compliment.
Yeah, I took it too. Thank you, Mr. Connor, for this amazing presentation, as always, you do. And you told about your voice, but your voice is perfect to hear. Like there's any problem, and we can hear you very well. And it was very pleasant to hear you. So right now, dear audience, dear attendees, you can ask any question regarding the presentation that was shown. Any case that you had some not clear part, or you have the question you like, feel free to ask. We have got several minutes for this.
I'll just put my contact details back up again.
Yes.
So if anyone ever wants to get in touch, I obviously, as you can probably tell, I'm happy to always chat about technology. And so you can get to me on my Twitter, on my blog, or my YouTube channel. If you search for The Spoken Nerd on any of your popular podcast applications, Apple, Google, Spotify, etc., you can find I do a podcast as well. And as always, happy to talk technology. Question, is it possible to use objects in PLSQL? There's an interesting history behind that. Way back around the Oracle 8 timeframe, which is about sort of 2002, I think. Anyone that's of my vintage will remember the world had moved from, or the world claimed it was moving from relational databases to object relational databases. And there's a few vendors that came and went and have long since disappeared. But it seemed like it was going to be the next big thing. And so Oracle in Oracle 8 released this thing called the object relational database. Nowadays, you'll probably see that when you do like create types, like create type object, create nested tables, etc. But back in the Oracle 8.0 timeframe, people were being encouraged to actually use those columns as data types in tables. You could actually create a table of some sort of complicated object data type. As a result, PLSQL had to evolve as well to actually handle those same data types. I think nowadays you would rarely find anyone using the object data types in persistent storage. They won't use them as columns, etc. Maybe advanced queuing's an exception to that. But the legacy of that is PLSQL happily has a very extensive language for handling object types and type evolution, polymorphism, etc. So PLSQL has all that. Not a lot of people use it, I'll be honest, because the world has sort of moved a little bit away from that now. But all the handling is in there. Probably the most common ones you'll see is in the later versions of Oracle. The way we manipulate JSON in PLSQL is all implemented with objects. So you can actually grab a big chunk of JSON, store it in a PLSQL object type. I think it's called JSON _object _t. And that particular object then comes with a whole lot of methods to do things like extract fragments, append fragments of the JSON, etc. So the object-oriented facilities and principles are all there in PLSQL as well.
Yeah. Questions? As we can see, there is no more question left, and we have got still some 3 minutes for Q&A. If there's anyone still something not clear left, feel free to ask.
I'll tell you what I do. I want to fire up those two swing bench clients again, because I think my machine was probably just struggling in terms of a CPU. So I want to get a more realistic number. So this is the swing bench client running, all the Java routines are running, all the SQL is being run straight out of Java. And this is more likely what I'd expect to see, sort of a consistent around about 200 and sort of 300 transactions per second. Mm-hmm. So what do we get? 277. And if I do SB server, normally I'd get about 350. But now I'm getting insane numbers. Mm-hmm. That's quite interesting. Normally I wouldn't expect the difference to be that large, but hopefully that really rams home the difference between, because this literally is two identical applications doing the exact same workload. One's doing SQL in the Java layer, and one that Java layer is calling PLSQL, and the SQL is being done in PLSQL. So on this particular machine, which is obviously just my laptop, we're getting from 300 to 530 transactions per second. It's pretty impressive.